Today's lesson, you might have to stop, pause the video so you can copy these definitions down, but we're just going to go right into it. We're talking about angles, and that's when you basically put two rays together so that they share an endpoint. For example, ray BC and ray BX both share B as an endpoint, so we call that formation an angle. When we're talking about an angle, you have to think about the amount of rotation from one side to the other. So if you were to turn in a circle or think of a clock, it's how much has the hand rotated. A vertex, if you don't remember, is the point. So in this case, the vertex is B. And when we name angles, there's 4 ways to name them. So you can name them with 3 letters, but the vertex has to be in the middle. So you can name it CVX. The other way you can name this angle is you could reverse the letters, XBC. You can name an angle with just its vertex, but that would not work if, for example, this was my picture, because now there's actually 3 angle B's in that picture. You have this whole one, this little one, and then our original. So that would not work. So I don't recommend you use that. And then the third way is you can always put a number in your angle, and you can name it angle, whatever number that is. So I would call this angle 1. We'll do that a lot when we do problems. If you don't remember the 4 types of angles, you should remember obtuse, acute, and right. Obtuse means more than 90, acute is less than 90, right is exactly 90. You must have a box drawn in here. If you don't draw the box, then it's not technically a right angle. It could be like 89.9 degrees. You probably didn't know, but lines are actually angles. So we call them straight angles. Okay, they're exactly 180 degrees. And that should look familiar when we were doing opposite rays. So you might want to make a note that opposite rays are also straight angles. Congruent, we learned, means same measure, all right, same size. So the way we're going to write that in math is we're going to write angle ABC, that's this angle here, is congruent to angle DFE, and that's right here. So that means that even though they're not physically the same size lines, the amount of rotation is still the same. So this looks like it's about maybe 38 degrees, and this is about 38 degrees. So when we show 2 congruent angles, we'll put these little arcs in here, and that signifies that they're congruent. So sometimes I might do this. I might put 2 arcs in the picture, and because they both have 2 arcs, they're congruent. Vertical angles will appear the entire year. We use those more than anything else. And you need to have 2 crisscrossing lines. And basically they're on opposite sides of each other. So 1 and 3 are vertical. And vertical angles are always congruent to each other. So if angle 1 is 100 degrees, then angle 3 is also 100 degrees. Angles 2 and 4 are also vertical. So vertical angles aren't side by side, they're directly across from one another. So then these would be 80 degrees and 80 degrees. So we would say angle 2 and 4 are also vertical, and hence they are congruent. So always look for crisscrossing lines, because as soon as you see that, you have to put in your own arc markings. So you have to do that yourself. So for example, if you see a problem like this, the first thing you should be doing is, since these are the angles that we're looking at, you should put arcs inside of these, and that says they're congruent. Congruent is fancy for equal. So one angle equals the other angle. So you're going to get x is 7. The angle addition postulate just tells you that you are totally allowed to add angles together to get the whole rotation. So for example, angle TRQ, that's this rotation, and angle TRS, that's this rotation, so from here to here, can add up to get you the rotation from start to finish. So in other words, you can add 40 and 83 together, and you're going to get 123 degrees for angle QRS. So the whole rotation is 123. Adjacent angles, they're a little bit trickier. So basically, they're angles that are side by side each other. So that means if you look at, say, RS and RT, if you look at that angle between those, it is exactly beside this next angle. So you have this angle, and you have this angle. You can see that they are just continuous. That's what adjacent means. It basically means continuous. There's no space between them. Supplementary means 180, complementary means 90. So angles that add up to 180 are supplementary. Angles that add up to 90 are called complementary. So if I want to know what's the supplement of 120, it'd be 60, because that makes 180. Same thing, if I want to know the complement of 30, that would also be 60, because they make 90. If I look at the next problem here, I see 90 degrees is the total. So x and 62 should add up to make 90, which would mean x is 28 degrees. Same thing with b. There's a total of 90 degrees. And my two portions are 2x plus 46 and 3x minus 6. So we're just going to set these up for right now. In letter C, I know if I add x and 40 together, I should get a straight line, which is 180 degrees. Same thing for letter D. If I add these together, I should get 180. So go ahead and pause the video, solve them, and then you can check your answers. Hopefully you got the same answers that I got. You just want to double check your math and make sure you're solving your equations correctly. We're going to do two more examples. I want to teach you guys how to read this. So this is pronounced measure of angle DBC. So DBC would be this angle here, and they're telling you that that is 4x minus 6. So I actually like to write 4x minus 6 in the problem. And then it says the measure of angle ADB, which is this angle, is 6x plus 2. So I'm going to write that in this angle. Okay, and then you're supposed to solve for x. So it's still a supplementary pair of angles. You can see it makes a line. So that means you need to add your two angles together and make that equal 180. And then you just go through and solve it. So save on time, you are going to get 18.4. It's going to be a decimal. Letter F, okay, so it says measure of angle DOC. So this is angle DOC, is 3x plus 20. So I'm going to put that in the angle. Angle COB is 10x minus 60. Angle BOA is equal to measure of angle DOC. So what I'm going to do is I'm going to put another arc in angle BOA, and I'm also going to copy the 3x plus 20, right? Because it says they're the same, so they should have the same expression. The last piece of information says measure of angle DOA is 100 plus 4x. So what you're going to do is you're going to add all these angles together and make it equal the overall angle, which is 100 plus 4x. So our setup's going to look like this: 3x plus 20 plus 10x minus 60 plus 3x plus 20, which equals 100 plus 4x. I went ahead and solved the equation, and when I did my work, I got x equals 10. So you took care of the first step, which was to solve for x, and then you're supposed to go back and find the number of degrees in each of these angles, now that you know what x is. So if I look at BOA, I'm basically going to do 3 times 10 and then add 20, and that's going to be 50. Then I'm going to do COD, and that's the same angle, so I'm also going to write 50. Angle BOC is going to be 10 times 10 minus 60, which is 40. Okay, so there's two ways to get the overall angle. You can add all of these pieces together, or you can stick 10 in for x, but either way, you're going to get 140.